Hello, my name is Çağın Şekerefeli and I'm a physics major studying in Bilkent University. The experiment that I'm going to present is about investigating the influence of mass and the string length on the period of a simple pendulum, with the objective of observing which of these magnitudes affect the period of the simple pendulum. The equipment that I have used in this experiment goes as such: a simple pendulum setup, a timer, 3 objects of different masses, a ruler, and an adjustable string. The pendulum system that I set up is a bit different from a regular pendulum setup, since to get rid of the rotation movement that the object made, I fixed the mass in 2 anchor points using strings of the same length, and then later on taking the length of the line perpendicular to the metal rod to use in the pendulum equation. For the first measurement, I arranged so that the length in between the 2 anchor points is going to be 28 centimeters. Later on, I found the length of the imaginary pendulum string, which was shown as the red line before, to be 13.6 centimeters using the Pythagorean theorem. I measured the time for the object to oscillate 20 times, which is 16.19 seconds in the first round as shown here. I did the same for 2 more times, which later on I took the mean value of. I divided the mean value to the number of oscillations to find the period of the pendulum, which is 0.81 seconds. To find the percentage of my error, I'm going to convert the pendulum formula, which is given here, to equate to the gravitational acceleration constant. After inserting my data into the equation, I get the experimental g constant to be 8.18 meters per second squared. Then I can calculate my percentage of error in this measurement to be 16.5%. Then I change the length of the string length that I'm going to use in the calculation by adjusting the distance between the 2 anchor points. After tabulating the data that I have acquired from 7 different systems with different string lengths, I get the overall error percentage by taking the mean value of the experimental g values, which is 8.99%. Here's a graph that I have plotted in which we can clearly see that the string length and the period is directly proportional. For the part 2 of the experiment, I used 3 different objects of masses 10, 50, and 100 grams. First, I calculated the time for 20 oscillations of a 10 grams mass, again using the same setup and the same equipment, which gave me 3 values, with one of them being 18.17 seconds as shown above, that I took the mean value of to be 18.26 seconds. We can see here with the tabulated data and the graph I plotted that the changing mass doesn't affect the period of the pendulum in any way. The percentage of error is also close to the part 1 of the experiment, which is 9%. The reason for this percentage in both of the experiments is mostly due to human error factors, since the measurement of the time for oscillations were made by hand using a stopwatch. The friction in between the string and the anchor point, also the friction in between the swinging mass and the air, the ruler being an unreliable tool for precise measurement of length, and outside manual factors such as the air movement of the room are also sources of error in this experiment.